Hey there. I hope you're excited to learn about cloud computing on AWS. I'm excited too, so let's go ahead and hop in. This week, we are going to cover some of the foundational concepts that you'll need to know about when working with AWS. Working with AWS is part theory, part technical knowledge, part vocabulary, and lots of practice and experimentation. This first week is going to help you establish a little bit from each of those categories. You will learn the theory behind cloud computing and the benefits of the cloud. This will help you make informed decisions about the cloud from a high level and give you some reasoning around why and when to use the cloud. Then we will dive into the AWS Global Infrastructure, covering both regions and availability zones, followed by lessons on how to interact with AWS resources. This portion of the week is going to give you the technical knowledge and vocabulary that you need to create and discuss AWS architectures and properly understand AWS documentation and examples. A lot of what AWS offers can relate back to concepts used on traditional on-premises computing. And getting started with AWS means comparing those concepts to AWS concepts. After that, we will begin to discuss security and identity and access management. This is important to understand when you're getting started because as soon as you create an AWS account, you'll have some actionable knowledge on how to secure that account right from the start. Starting off secure is a good place to be. Throughout all of the topics this week and over the duration of the entire course, we will be using a sample employee directory web application to demonstrate how AWS services are used, and we'll be using the same application to give you some hands-on experience through exercises done in your own AWS account. Let's go ahead and take a look at the employee directory application. You can see I am already in the browser and I have this employee directory application up and running. And what I want to do now is show you the functionality of this app. This is a basic CRUD app or a create, read, update, delete application. This app keeps track of employees working within a company. So the first thing I want to do here is create a new employee. So to do that, I'm going to go ahead and click add. And then I'm going to give the employee a name. I'm just going to add myself here. My location is USA. My title is Senior Cloud Technologist. And then you have the ability to add some badges to employees. So I'm going to go ahead and select Mac user, frequent flyer, and coffee snob for myself. So I'll go ahead and click save. And that you can see now we have the saved banner popped up and we're back on the home page. And I actually forgot to add a picture for myself. So I'm going to go ahead and click on the employee. And then I'm going to click the edit button. And now I'm going to select a file here, which is just a picture of me. And then I'll click save. And now we can see that this employee has a photo. One more thing that this app can do is we can delete employees. So I'll go ahead and do that. And now you can see we have an empty directory again. And then one final thing to know about is we have something called an info page. And this gives some information about where the app is hosted, and this will come in handy later on in the course. So those are the features of the app from a user's perspective. Time to review now how we will build this app using AWS services. This application will be built in a private network using Amazon Virtual Private Cloud or VPC. We will host the application's backend code on Amazon Elastic Compute Cloud or EC2, which is a service that essentially offers virtual machines on AWS. So let's go ahead and add those servers to our diagram as well. The employee data will be stored in a database, which will also live inside of this network. And this will be hosted using a service called Amazon Relational Database Service, or RDS, or we might be hosting it on Amazon DynamoDB. So we'll add both of these to our diagram. The images for the employees will be stored using the object storage service, Amazon Simple Storage Service, or what we call S3, which will allow the unlimited storage of any file type, like the images in this example. So these are the basic building blocks of our application, but we're not done yet. We are also going to use Amazon CloudWatch for monitoring this solution. And we want to ensure that our application is scalable and fault tolerant. So I'm also going to add an elastic load balancer here, which will distribute the traffic across the EC2 instances. And we will also add Amazon EC2 auto scaling to this diagram. So that way our solution can scale out with demand and scale in when demand decreases. For security and identity, we will be using Amazon Identity and Access Management, or IAM. So you can see that there are a lot of different pieces on this diagram, but don't worry. We are going to build this app step by step using the AWS Management Console. We will add to this diagram, reference it, and change it throughout the course to meet our needs, and we're going to let it evolve as new ideas and techniques enter our world. One more thing to note about this course before I let you go. If you hear this noise, it means that you are going to be seeing one of our informational pop-ups on the screen, which convey extra information like word definitions, AWS best practices, tips and tricks, or general commentary written for you by our lively furry sidekicks, Meowsy and Kiwi. They know all the tips and are very helpful little friends to have around during this course. So that's it for now. Have fun and make sure you complete both exercises for this week so that you can start working hands-on with AWS.
For our employee directory application, we'll be using photos of each of our employees. We have to store them somewhere safe. Currently, the only copy of these photos are saved on my laptop right now. But if my laptop breaks, then what happens? No more photos. I want to make sure this doesn't happen, so I'm going to upload the photos to AWS to ensure that the copies exist even if my laptop is destroyed. This also allows me to access my photos from anywhere. My home, my phone, a plane, on a train, everywhere. When I store these photos in an AWS service, unbeknownst to me, I'm storing it in a data center somewhere, and servers inside that data center. But if a natural disaster happens, or a fire, or let's say a giant lizard comes out of nowhere, stomps on the data center, then what do we do? Luckily, AWS has planned for this event and many others, including natural disasters and other unavoidable accidents. The way they plan for it is through redundancy. AWS clusters data centers together around the world. So here, AWS might have a second data center connected to the first data center through redundant high-speed and low-latency links. That way, if the first data center goes down, the second data center is still up and running. This cluster of data centers is called an availability zone, or AZ. An AZ consists of one or more data centers with redundant power, networking, and connectivity. Unfortunately, sometimes natural disasters like hurricanes or giant lizards might also extend to impacting an entire AZ. But AWS has planned for that too, with redundancy. Like data centers, AWS also clusters AZs together and also connects them with redundant high-speed and low-latency links. A cluster of AZs is simply called a region. In AWS, you get to choose the location of your resources by picking a region. Regions are generally named by location, so you can easily tell where they are. For example, I could put our employee photos in a region in Northern Virginia called the Northern Virginia region. And remember, AWS is not going to name a region in Germany after Northern Virginia. As a basic rule, there are 4 aspects you need to consider when deciding which AWS region to use: compliance, latency, price, and service availability. Let's start with compliance. Before any other factors, you must first look at your compliance requirements. You might find that your application, company, or country that you live in requires you to handle your data and IT resources in a certain way. Do you have a requirement that your data must live in the UK boundaries? Then you should choose the London region, full stop. None of the rest of the factors even matter. Or if you operate in Canada, then you may be required to run inside the Canada Central region. But if you don't have a compliance or regulatory control dictating your region, then you can look at the other factors. For example, our employee photos are not restricted by regulations, so I can continue looking at the next factor, which is latency. Latency is all about how close your IT resources are to your user base. If I want every employee around the world to be able to view the employee photos quickly, then I should place the infrastructure that hosts those photos close to my employees. We are all bound by the speed of light. Applied to your business, that means if all your users live in Oregon, then it makes sense to run your application in the Oregon region. You could run it in the Brazil region, but the latency from Oregon to Brazil might impact your users and create slower load times. But maybe I really want to run my application or store my employee photos in Brazil. One problem I might run into is the pricing, which is the next factor we'll talk about. The pricing can vary from region to region, so it may be that some regions, like the Sao Paulo region, are more expensive than others due to different tax structures. So even if I wanted to store my employee photos in Brazil, it might not make sense from the latency perspective or the pricing perspective. And then finally, the fourth factor you'll want to consider is the services you want to use. Often, when we create new services or new features in AWS, we don't roll out those services to every region we have right away. Meaning, if you want to begin using a new service on day one after it launches, then you'll want to make sure it operates in the region that you're looking at running your infrastructure in. To recap, regions, availability zones, and data centers exist in a redundant, nested sort of way. There are data centers inside availability zones and availability zones inside regions. And how do you choose a region? By looking at compliance, latency, pricing, and service availability. When you own the infrastructure, it's easy to understand how you interact with it, because you can see it, touch it, and work with it on every level. If I have a server that I've stood up in my closet, interacting with that server is easy because it's mine. I can touch it. When I remove the ability for me to touch and see something, when the infrastructure becomes virtual, the way that I work with that infrastructure has to change a bit. Instead of physically managing my infrastructure, I now logically manage it through the AWS Application Programming Interface, or API. So now when I create, delete, or change any AWS resource, whether it's a virtual server or a storage system for employee photos, I use API calls to AWS to do that. You can make these API calls in several ways, but the three main ways we're going to talk about are the AWS Management Console, the AWS Command Line Interface, and the AWS Software Development Kits, or SDKs. When people are first getting started with AWS, they'll typically use the AWS Management Console. This is a web-based console that you log into from your browser. The great thing about the console is that you can point and click. By simply clicking and following prompts, you can get started with some of the services without knowing anything about the service. With the console, there's no need to worry about scripting or finding the proper syntax. When you log into the console, the landing page will show you all of the possible services that you can work with, organizing them into relevant categories such as compute, databases, storage, and more. On the upper right-hand corner is where you select the region you want to work in. Changing the region directs the browser to make requests to that region, represented by a different URL. If I change the region to Paris, you're making requests to eu-west-3.console.aws.amazon.com, or the Paris region's web console. After you work with the console for a while, you may want to move away from the manual creation of resources. For example, in the console, you have to go through multiple screens to set configurations to create a virtual machine. And if I wanted to create a second virtual machine, I would need to go through that process all over again. While this is helpful, it also leaves room for human error. I might miss a checkbox or misspell something or even skip important settings by accident. So when you get more familiar with AWS, or if you're working in a production environment that requires a degree of risk management, you should move to a tool that enables you to script or program these API calls. One of these tools is called the AWS Command Line Interface, or CLI. You can download this tool and then use the terminal on your machine to create and configure AWS services. Instead of having a GUI to interact with like the console, you instead create commands using a defined AWS syntax. For example, if I wanted to launch a virtual machine, I first type in AWS, which is how we know we interact with the API. Then type in the service, in this case, which is EC2, the service that allows us to create and manage virtual machines, which we'll learn about later, and then the command that we want to perform in that service, and then any other configurations we want to set. One command versus multiple screens you have to click through in the console can help reduce accidental human errors. But that also means you have to work with defined syntax and get that syntax correct in order for your command to run successfully. So there is some upfront cost in just understanding how to form commands. But after a while, you can begin to script these commands out, making them repeatable, which will save you time in the long run. The other tool that allows you to interact with the AWS API programmatically is the AWS Software Development Kits, or SDKs. SDKs are created and maintained by AWS for the most popular programming languages, such as Python, Java, Node.js, .NET, Ruby, and more. This comes in handy when you want to integrate your application source code with AWS services. For example, our employee directory application runs using Python and Flask. If I wanted to store all the employee photos in an AWS storage service, I could use the Python SDK to write code to interact with the AWS storage service. The ability of managing AWS services from a place where you can run source code with conditions, loops, arrays, lists, and other programming elements provides a lot of power and creativity. All right, that wraps up this video. To recap, you have three main options to connect with AWS: the console, the CLI, and the SDKs. And this course will mainly be using the console to interact with the services. But feel free to challenge yourself by using the CLI if you're a bit more advanced.